Well, welcome. We're going to attempt to cover 5 sections of Chapter 3 over the next few videos, and then we'll cover the rest of the Chapter 3 sections in the next few days. If you recall, the definition of the derivative is how we started out Chapter 3 back in Pre-Calc Honors. And the definition of the derivative, we're going to get into that here in a second, but keeping in mind that the derivative of a function is the instantaneous rate of change of that function. So in other words, if you're talking about average rate of change versus instantaneous rate of change, average rate of change is pre-calc and instantaneous rate of change is calculus. We need limits and we need to incorporate those into our finding the instantaneous rate of change of a function. So if we look at this function here, let's say this blue curve, it could be any curve as long as it's a function, continuous along its domain here, and if we find 2 points on this curve here, one point here right above the x, and then one point here if we go out h units away from x and we map another point onto the curve, we find that the coordinates of this first point are x comma f of x, and the coordinates of this point over here are x plus h comma f of x plus h. Okay, I should probably put another, where's my green? I need my green. Okay, there we go. So our initial thought is we really want to find the slope right here of this orange line segment. This orange line segment here represents the tangent line to the curve y equals f of x at the point x. In other words, the instantaneous rate of change of the function f of x right here at this point. Okay, so our goal is to find the slope of the tangent line, which is what the derivative is as well. And we're going to use the slope of we call this the secant line, the line that intersects this curve y equals f of x at 2 points. Okay, so we can easily find the slope of the secant line, and as we let h, the distance between these 2 points along the x-axis, as we let h go to 0, the slope of the secant line becomes the slope, or approaches the slope of the tangent line. And that's where we involve the limit and the definition of the derivative. And so we have the limit f prime of x, which is what this is. Okay, so we have y equals f prime of x, which is the slope of the tangent line right here, is h, the limit as h approaches 0, of f of x plus h, so the difference in the y coordinates, all over the difference in the x coordinates. And x plus h minus x is just h. So there's one of the definitions of the derivative. Now we have another couple definitions of the derivative. We have f prime at a. If we wanted to substitute in a for x, this is also a very important definition of the derivative. Now here we have the derivative of this function at a particular value a, and that would be where we just replace x with a in the above definition. So that's an important one. And then we also have a kind of a not used quite as often definition, but it's still a definition. As we let x approach a, we have the limit as x approaches a of, f of x minus f of a all over x minus a. You need to be familiar with all three of those, and we're going to do some problems here in a little bit, but for right now we're going to keep it at that. We have worksheet 3.1, and I'm going to do problem number 7 from that worksheet, but I'm going to do that in the next video because I don't